Alright guys, so today we're looking at the 4.6 notes, which are finding all rational zeros being the ones that are not imaginary. So what are three other names that we have for solutions or answers? Well, these are important. They come back over and over and over again. We call them roots, we call them zeros, and we call them x-intercepts. Alright, those are the three different names we have for the solution to any type of polynomial equation. So we've been doing problems where I give you a solution to a polynomial and you find the rest of the factors and solutions. For instance, let's try this one. We have f of x is equal to x cubed minus x squared minus 17x minus 15. We know that f of negative 3 is equal to 0. So this tells us that the x-intercept is negative 3. Or we know that the factor is x plus 3. So we use that information to now divide this polynomial into something that is factorable. So we take negative 3, we do synthetic division, 1, negative 17, and negative 15. Drop the 1, multiply, you get negative 3, add together to get negative 4, multiply negative 3 and negative 4 to get 12, add again to get negative 5, negative 3 and negative 5 is positive 15, add again and you get 0. From right to left, you should have the remainder, the constant, the x, and the x squared. And then this makes sense because we're dividing a cubic by a singular x, so then our solution that we get should start with an x squared. So that gives us x squared minus 4x minus 5, which factors into x minus 5x plus 1. So if we're listing all of the factors, we have that x plus 3 that we started with, and then x minus 5, and then x plus 1. To find the solutions, you just set each of those factors equal to 0, and you solve for x. So x equals 5, x equals negative 1, and x equals negative 3. All right. So that's what we've been doing. On to the new stuff. What if I give you something that's unfactorable, and I don't tell you any of the solutions or factors? So here's an example. All right, f of x is equal to 3x cubed minus 2x squared minus 61x minus 20. There's a way that mathematicians figured out to find the possible rational zeros, and it's right here, okay? So a list of our possible rational zeros can be found by finding the p's over q's, which are the factors of the constant term divided by the factors of the leading coefficient. So let's try it with this. P's over q's are actually always plus or minus, so it can be the positive version or the negative version. So the factors of our constant term, those are the p's. So that would be 1 and 20, 2 and 10, 4 and 5. The factors of the leading coefficient are 1 and 3. So then how I would write this is I would say plus or minus. And now what we have to do is we have to put all of the p's over all of the different q's. So start with the plus or minus, and then I go parentheses. 1 over 1 would be the first term, right? 1 over 1. And then we would have 2 over 1. And then 4 over 1, 5 over 1, 10 over 1, and 20 over 1, which you don't need to write over 1. You could literally just write the numbers as well, okay? So once you understand that you're just dividing all of those things by 1, that's all you need. And then on top of that, now we need to do all of the p's over all of the q's that are 3, so it would be 1 over 3, 2 over 3, 4 over 3, 5 over 3, 10 over 3, and 20 over 3. The list that we just built is every possible solution. So in the grand scheme of this, because this is an x cubed, there's only 3 possible solutions. So out of these 1, 2, 3, 4, 5, 6, 12 possible solutions, it's possible that only 3 of them work, and it's even also possible that only 1 of them works. So it doesn't really get us that low on what the factors could be, but it gives us a great starting point, okay? So now it says figure out which possibility will work. So now what we literally have to do is we just have to start guessing and checking with our synthetic division. So let's try 1 first. So if we do 1 with synthetic division, because right, we have positive 1, that would give us 3, negative 2, negative 61, negative 20. So we drop the 3. 3 times 1 is 3, negative 2 plus 1, 3 is 1. 1 times 1, negative 60 plus 1 is negative 60. Negative 60 times 1 is negative 60. So we add these and you get negative 80. All right, so it turns out that 1 does not work for us. Okay, well, if 1 doesn't work, well, maybe negative 1 will work. And I pick these numbers because they're pretty easy to just plug in and start guessing and checking. So let's do it again with negative 1. We have 3, negative 2, negative 61, and negative 20. So then we drop the 3. 3 times negative 1 is negative 3. We add, and you get negative 5. Negative 1 and negative 5 is positive 5. Negative 61 and positive 5 is going to be negative 56, right? And then we're going to get positive 56, not 0 again, okay? So this does tell us one thing, though, right? If we go negative 20 plus 56, that's going to give us 36. This does tell us one thing. Between 1 and negative 1, we went from negative 80 to positive 36. There's a 0 somewhere in there. Okay, so that's telling us that one of these fractions, oops, sorry, not the 4/3, either 1/3 or 2/3 is going to be a solution that works. And that's because, right, if you plug in 1, you get out negative 80. If you plug in negative 1, you get out positive 36. So, narrowed it down to 1/3 or 2/3. So then we're going to go, I don't know, let's go 1/3. See what happens. 3, negative 2, negative 61, negative 20. So that's 3. That's going to give us positive 1. Actually, it could be positive 1/3 or negative 1/3. Let's go negative 1/3. Negative 1/3 looks nicer. So 3, negative 1. You add this and you get negative 3, right? And then we go 1/3 and negative 3, which makes 1. So that's negative 60. And then negative 1/3 of negative 60 is 20. There's our 0. Boom. Okay, we found the 0. So that tells us that x equals negative 1/3 is a solution. It also gives us this new equation, 3x squared minus 3x minus 60. So we can factor out a 3, which gives us x squared minus x minus 20. So that's going to be x minus 5 and x plus 4. So then our other two solutions are x equals 5 and x equals negative 4. And there we go. All three of the solutions for that problem. Okay? Say that we got this and it didn't factor, well then we're back to the drawing board. Okay, we're starting to pick different numbers. 1 would already have not worked. Negative 1 didn't work. We were seeing that negative 1/3 also did not work. So then I would start going up. I would do 2, 4, 5, so on and so forth. Okay? But Mrs. Horn and I actually don't ask you to do anything of that nature, really. So, what would be an easier way to find all the zeros? Well, of course, using our graphing calculator. So that's exactly what we're going to let you guys do come a test. So it says find all the factors and solutions for f of x for that function. You may use your calculator to get you started after listing the p's and q's. Then find all the zeros algebraically. You can use your graphing calculator to verify the answers at the end. So, doing this question, you need to start with your p's and q's. So our p's are all the factors of 175. P's always go over q's. So that's going to be 1, 175, 5, and 35, 7, and 25. 1 is the only q, so our q's are just 1. So our list of p's over q's are plus or minus 1, 5, 7, 25, 35, and 175. That would be the list of all of the p's over q's. Do not forget the plus or minus, because it could be plus or it could be minus. I would let you use your graphing calculator. What you would look for in the graph is a spot where it crosses the axis, okay? In this particular case, I know that this one crosses at -7. So we're going to plug in a -7 into our synthetic division. So we have 1, -2, -45, and then 175. We drop the 1. That gives us -7, which gives us -9, which that then gives us -7 times oops, I messed that up, sorry. This is a 3, -3 here, which makes us -10. -7 and -10 makes positive 70. -45 and 70 makes 25. And then we get -175, which gives us 0. So from here we have a new equation, x squared minus 10x plus 25, which would factor into x minus 5 and x minus 5. So the factors for this equation are x plus 7, right, that -7 that worked. And then you could say x minus 5, or you can just say x minus 5 squared. Those are both great. So then our solutions are x equals -7 and x equals 5. And that's how you would do a question like that. Okay? So, let's run through another one. List of p's over q's. So our p's are going to be 1 and 8, 2, and 4, right? Because those are the only factors of 8. And then our q's are going to be factors of 5, so just 1 and 5. So when we're listing these p's over q's, plus or minus out front, because it can always be positive or negative. And then we have 1 over 1, we have 8, we have 2, and we have 4. And then we have 1 over 5, we have 8 over 5, 2 over 5, and 4 over 5. Those would be all the p's over q's. Use your graphing calculator, find the solution, and then solve algebraically. So we'd plug it into our graphing calculator. We'd see some kind of random graph. No idea what it looks like, really. It's been a while since I plugged that in my calculator. But I do know that it crosses at -2. So you would see this. You would say, okay, crosses at -2. So then we would use -2 in our synthetic division. So we'd go 5, -1, -18, and 8. Drop down the 5, you get -10, which gives you -11. -11 and -2 is positive 22, which gives you 4, which gives you -8, which gives you 0. So then our equation is 5x squared minus 11x plus 4. This equation, notice the hint says, pop goes the weasel, can actually not be factored. So instead, what we have to do is we have to say, okay, x is equal to the opposite of b, so -11, plus or minus the square root of b squared, which is -11 squared, minus 4 times a, which is 5, times c, which is 4. All of that divided by 2a, which is 2 times 5. Okay? I will let you guys practice simplifying this on your own, because we definitely still need more practice with that, but it should simplify down to 11 plus or minus the square root of 41 over 10. So what are our solutions? Our solutions are x equals -2, and then 11 plus or minus the square root of 41 all over 10. Okay, those would be the 3 solutions. When writing the factors of this, we have options. Okay, I like us to write x plus 2. All right, and then because that other one didn't factor, you can say 5x squared minus 11x plus 4. Or you could get fancy, you could say x plus 2, and then you could say x minus 11 plus radical 41 over 10, and x plus 11 minus radical 41. Oops, sorry, not x plus. Another x minus 11 minus radical 41 over 10, because that would give us our plus and our minus versions of that crazy radical. So that's what we're doing there. Sometimes we might have to use quadratic formula because we get irrational numbers, because irrational numbers also are solutions to polynomials. Sorry. So this next one, another example, says find all of the zeros to the factors of the solutions and solutions to this equation. Sorry. It says after you do synthetic division with the first zero, you still won't be able to solve, so you'll have to do synthetic division again with another zero and your new coefficients. So how does this one work? Our p's, all right, so the p's are going to be 1 and 6, 2 and 3. The q's are going to just be 1 because 1 is the only coefficient on the first term. So then our p's over q's would be plus or minus 1, 2, 3, 6. If for some reason you ever had q's that were 1 and 2, you would not need to say 6 over 2. You also wouldn't need to say 2 over 2 because that would be a repeat of 1 and a repeat of 3. All right, so you never have to repeat terms. But I'm not going to count you off for writing a term twice. Not a huge deal for me. Okay, so we go to our graphing calculator. We find that one of the zeros is 1. So we go 1, 1, 5, negative 1, negative 6. And we go through the process. Drop the 1, gives us 1, 2. 1 times 2 is 2. 5 plus 2 is 7. 7 times 1 is 7 still, which gives us positive 6. Positive 6 gives us 0. So that's remainder constant x squared, x cubed. So that's x cubed plus 2x squared plus 7x plus 6. All right. We used our graphing calculator again on this actually you could use the first equation still. And we saw that another 0 was negative 1. Well, we're going to use that negative 1 on the new equation we built. So 1, 2, 7, and 6. Drop the 1, gives us negative 1. Negative 1 and 2 gives us 1. Negative 1, which gives us positive 6, which gives us negative 6, which gives us 0. Now we have a remainder constant x and x squared. So we can actually say x squared plus x plus 6 to find the last zeros, right? So this is x plus... Wait, did I get that right? Should I have had a negative somewhere? Negative 1. I don't think that factors again, right? Yeah, it does not factor again. So we'd have to come back through, because that's x squared plus x plus 6. And go quadratic formula on this. Yes, we would. X equals negative b plus or minus the square root of b squared, which is 1 squared minus 4 times a times c, all over 2 times a. So that's negative 1 plus or minus the square root of 1 minus 24 over 2. And then negative 1 plus or minus 1 minus 24. Negative 1 plus or minus the square root of negative 23 over 2. So that's going to give us negative 1 plus or minus I radical 23 over 2. So our factors, how would we write the factors for this? We would say x minus 1, that was this first factor. We would say x plus 1, that was the second factor. And then our last factor is x squared plus x plus 6, right? Because this did not factor, we had to use quadratic formula there. For our solutions, we say x is equal to 1, negative 1, and then negative 1 plus or minus I radical 23 all over 2. All right, and then there's our final solutions. So these questions are kind of cool because they're starting to put together everything we've done, right? We do synthetic division, then we have to get it down into something that's factorable, or we have to use a quadratic formula for, and then we find the x-intercepts and the factors. All right. If you have any questions, please let me know. All right. I hope you guys have a great day.